Magandang umaga and mabuhay. Good morning and long live everyone on this call. I'm so pleased to be with you here today. My only regret is that I couldn't be with you in person. I am enjoying New York City Climate Week, though. There are many, many events, as you can imagine, and very exciting news to be shared all around. I'd like to share my screen and spend a few moments with you today talking about the topic that you structured this series around, which happens to resonate very well with what I can hear happening in New York City Climate Week this week, which is moving from analysis to action. The level and technical depth of the questions that I've been getting and the questions that people are asking is dramatically increasing, which is great. That means people are starting to work on taking action to not only actually mitigate their emissions, but also to protect themselves and to adapt to the climate change that we've already bought ourselves, if you will, committed ourselves to. So today I'd like to talk about a bit on motivation and are we on track? Spoiler alert, no, we're not. And physical risks, what kinds of things we can expect there. Talk about the materiality of the financial impact of physical climate risk and transition risk. Tell you a little bit about how we're approaching the methodologies of both macroeconomic and microeconomic analysis of climate risk. How would you know how much this costs you? Mainstreaming from analysis to action, what are corporates doing and how and why? And then finally, just a few words on what I see as some of the big challenges that we can all work on together. So are we on track? Let's reground ourselves in the actual fundamentals here. This is the trace of CO2 in the atmosphere. So this is not emissions. This is the actual concentration of CO2 in the atmosphere, which is the only thing that matters to drive the climate change that we're seeing. So there's other greenhouse gases, but I'm just saying CO2 is the main one. And you can see that it has taken this course upward since we started measuring it on Mauna Loa back in the late 50s. I want you to look at this graph and see if you can see the effects of the pandemic. Now I want you to look at this graph and see if you can see the effects of the Paris agreements. How about the net zero pledges that have been made around the world? I can't see any of those. So this is what matters. And as we go through the rest of our talk today, let's keep in mind that it's the actual carbon dioxide in the atmosphere that matters. One more question for you. Can you locate the year of your birth and what the parts per million of CO2 has done since then? I was born somewhere in here. So continuing with are we on track? Now this graph is about the emissions of greenhouse gases, not the concentration, but the emissions. The emissions have also increased since the late 50s. And here you can see the black line is historical. And then you can see over here on the right, here are the NDCs as nationally determined contributions from the IPCC process. And then INDCs is intended nationally determined contributions. So in red is what we've said we will do, in gray is what we said we might do. And I will point out that the red has not been uniformly enacted into countries' laws. Well, the blue is what the emissions need to be to keep us below 2 degrees C by the end of the century. And the green is, or teal is 1.5 degrees. So you can see there's a little bit of overlap between the if we implemented the nationally determined contributions and it went well, maybe we could get into the 2-degree range. I'm going to break that down just a little bit more. This is the same y-axis and the same similar x-axis. But here you can see the effect of the pandemic. This is emissions, keeping in mind. And you can also see how the emissions have been increasing at rates between 1 and 3% per year. And yet these 2-degree and 1.5-degree scenarios assume that we're somehow magically going to start decreasing emissions much faster than we've ever increased emissions. So I want us all to, as we go through this talk and as you go through the rest of your career with climate, keep in mind the just a set of common sense questions. Is this realistic? Is what I'm looking at agree with my common sense? So I hope that that's motivation enough to dive into the physical risks and start to understand why physical risk assessments and scenario analyses in particular can be very valuable tools for business. This is just a visualization of what happens to the Adelaide, Australia airport. On the left is 2 degrees of warming, on the right is 3 degrees of warming. You can see that there's a threshold in between 2 and 3 where the asset goes from being sort of having maybe a little annoyance level flooding up on the left to being completely irrelevant. So some of you have already submitted questions about the new exciting airport that's being built near Manila. And I would urge us to keep in mind that there are thresholds, some of which in the case of the new airport are much closer to 2 degrees or perhaps even below 2 degrees, after which the world becomes quite different quite suddenly. So here's another map. This is probably stuff that you are quite familiar with. This comes from Climate Central, and this is also 2 degrees in of tidal flooding. So this is the teal color, the greenish color is when the areas will have the high tides will flood the land, and Bulacan is already, as you know better than I do, experiencing some degree of flooding. And then the red is if you go up to 3 degrees. So that the good news is the difference between 2 and 3 is not too terribly much along some of the coastline, and yet the bad news is that 2 degrees is not what we want to see. A couple of other pieces of motivation and physical risk. Heat is clearly a factor, and dangerous heat in this study is defined as days when the heat plus the humidity becomes dangerous for people to spend time outside. In the sun is yellow, in the shade is purple. The good news is that if you get into the shade, you're going to be okay around Manila. But you can see that the days have in the sun where the dangerous heat is rising from about, let's say 45 to 90, which is, most of the summer. That's not so good. And then probably a topic that's you're quite well aware of is the impact of typhoons. I just want to share with you, this is unpublished work that I'm sharing with you from my team, my research team at S&P Global. We did a bunch of modeling looking at the various different ways in which typhoons can affect the land. As you know, there are changes in frequency, that is to say the frequency of formation of hurricanes, but there are also very important changes in the path that the hurricanes will take, or typhoons will take, as well as the intensity, both wind and water. Sometimes there has been an observed trend in slowing down of typhoons so that they dump more water and they can hold more water. The good news is that you can see on the top row, category 0 is on the top row, category 1 plus is on the next row, category 3 plus is on the third row, and category 4 plus is on the bottom row. And all of them show that there's actually going to be less incidents of landfalling hurricanes. This is not speaking to their intensity or their wetness, their ability to dump water, but rather the path is tending poleward in both hemispheres. So in this case, northward, which might lead to fewer landfalling hurricanes that have greater strength. So this is unpublished work, but I wanted to share with you that the state of the science is still evolving quickly on typhoons. I want to now journey into materiality. So we've set up the kinds of things that you're quite well aware of, I'm sure, about the impacts of physical risk. Let's look at the financial materiality of this a bit. The first graph that I find quite useful is a study that S&P did back in 2018, and it broke down the materiality of weather and climate events as reported by the CFOs and the CEOs of publicly held companies when they missed their earnings and blamed it on the weather. I don't want to be too crass about that, but frankly, when they were impacted by weather and climate events. And you can see that the degree to which it impacted their profitability or their earnings, frankly, was between, let's say, 13% and 1%. So it varies greatly by the sector. And remember that these aren't predictions. This is reported historical materiality. So we can keep these numbers in mind as we go through the next couple of data points. My apologies for the huge number of graphs that I'm displaying at you here, but this is a very interesting study on the impact on global gross domestic product, or GDP. And this is from a paper a few years ago, 2018. And you can see that by the mid-century, 2049, various different scenarios, these correspond to different emission scenarios. Various different scenarios show different levels of GDP impact, but they're all between a few percent and let's say 10%. Well, that's not too dissimilar from the graph that we just looked at. Now, the issue is when you look out a little bit farther and you look at what would happen if we got to 2 degrees, or frankly, if we meet the Paris Agreement, will be more like 2 point something, 2.67, something like that. And then we're talking about a much higher degree of change to GDP, impact to GDP. This is some work that my team did. This is unpublished research again. And you can see that we've scoured a number of different assessments, and the range of impacts is quite wide, but some of them could be quite damaging indeed. This is from a wonderful document that the World Bank released last year called the Philippines Country Climate and Development Report. I hope that you all are familiar with it. It has a wonderful range of practical suggestions. And you can see that in the Philippines, the range of the possible impacts is quite large and also quite significant. One of the ways that it affects, that climate change could affect the Philippines is, of course, crop yield impact. And I believe my colleague is going to talk a little bit more about some of these impacts, so I'll go quickly. But I did want to say that from this report, one of the striking conclusions is that adaptation, investing in adaptation, that is to say, preparedness for the risks that we expect is an extremely advantageous investment and can shift the loss of GDP quite significantly. I want to talk for a moment about how we do these physical risk assessments. I think I hope you agree with me that they can be quite advantageous to business to understand what your risks are and then be able to adapt to them. So now, how do we do that? And how can it be available to you? So this is a picture from the Task Force on Climate-Related Financial Disclosures. And this breaks down a process for understanding how physical risks and transition risks flow through both strategic planning and financial impact into a company's financials. I will talk about microeconomic approaches and then very briefly about a macroeconomic approach. The microeconomic approach starts with scenarios, then looks at assets, actual physical things that you own, understands the hazards that those assets are exposed to, and then assesses the vulnerability of each thing, each asset to each type of hazard, and from there calculates the risks or estimates the risks. You're probably familiar with the NGFS or greening the network for greening the financial system scenarios. These are some of the sort of emerging standards, and they range from very high transition risks to very high physical risks. And here are the emissions that various different scenarios assume. You can see that I might, from our earlier discussion, you can see that I might encourage us to be very, let's say, mindful of what assumptions we make that sometimes starting in 2020, there's going to be rapid decrease. But you can see that here we're looking at a range of temperature increases. This is to show that there are other scenarios also. There are many different scenario frameworks, including some scenarios that S&P itself has developed that are trying to be a little bit more realistic based on what we know industry to be actually doing. So for example, this orange dotted line, the inflections scenario, is based on actual energy supply and demand modeling. Energy balance modeling, and here you can see a range of other scenarios. So somewhere in the middle there is where we think is most probable based on what industry is actually doing. So once you've understood the scenarios or selected a scenario that you want to model, then it's important to look at the hazards that will be that each asset will be exposed to. And so here, for example, is temperature. And as you can see, temperature increases fairly gradually at most assets. And we look at several different hazards that I'll show you in the next slide, I think. But after that, that is not the end of the story. If you ever see hazard maps and just say, okay, well, it's going to get hotter here, drier, wetter, colder, etc. That is not the end of the story. You have to then understand what's the vulnerability of an asset to that hazard. And I'll give an example. If you had a field of, let's say, I don't know, wheat or something, and you had an office building, and they were both exposed to a heat wave and a drought at the same time. This was a region-wide heat wave, and it was very extreme. You can see how it wouldn't affect the office building's financials at all, whereas it would affect the field of wheat or the agricultural asset. So that's where, and these effects can be quite non-linear, and this is why you have to go through and assess the vulnerability of each one. And that's how you get the actual financial implications. That's something that we'll come back to in a moment. The financial implications is how we mainstream this work into business and make a decision actionable and relevant. Here you can see a number of the physical risks that we assess: temperature extremes, coastal flooding, drought, wildfire, tropical cyclones, water stress, fluvial flooding, which is river-based flooding, and there's actually another one now, which is fluvial or rain-based flooding. Let's just look at this diagram to get the flow. Imagine a coastal flood. Well, then you look at what type of asset is exposed to that flood. In this case, it might be an urban high-rise. And then you start to try and understand, how would this cause financial damages? Well, I have to clean up the damage. I have to repair any damage, and that will increase my expenses and therefore reduce my net income. I also have to deal with the fact that I might have rental income loss, which decreases my revenue, which decreases my net income. And then I might actually damage the asset itself, which would impair its book value and affect my balance sheet. So you have to look at many different asset types. We're looking at over 270. We run this analysis at S&P against over 1.6 million assets. And that's what the company that I created and is now part of S&P did. We tried to do this at scale. In the intro, we were talking about how can we bring this to small and medium-sized businesses, and how can we scale this up? Well, it has to be, the answer is not just go hire a consultant, because that's usually cost prohibitive. This has got to be run by technology, and we'll see some wonderful examples from that from my colleague next. Just a few screenshots to give you an example of what can be done with the technology system. Here's a set of assets that can be looked at together as a portfolio. Here are some agricultural assets, and over on the left, you can see the actual financial estimated impact for a given scenario up in the right and a given decade. And you can break it down by what causes the damage. I'm going to look at a different, just a single asset now. And this one happens to be, let's see, a cotton farm. It looks like in Pakistan. And you can see that there's a nonlinear response here. And you can right away see that you've got some temperature extremes causing some damage here. Well, you can click on that and see here's what's going on with the hazard. The temperatures are, of course, increasing, and the vulnerability as a function of the hazard is depicted here. I'm going to look at a slightly more interesting one. This one happens to be in the Philippines. It also happens to be a cell tower, which is not terribly interesting, but you can see that the financial impacts are non-linear here. And you can say, well, what's going on there? And the answer is the increase in the hazard, in this case flooding, is non-linear, as it tends to be. And also the impact, the vulnerability is non-linear. So you can get some rapid changes over time, even with what we think of as fairly slow progression. So I promised you I was going to talk about macroeconomic modeling. And I promise you I will not go through this slide, but one of the ways that you can approach a top-down or macroeconomic model is to use a probabilistic approach. So you in Bayesian network modeling, you try and understand what are the key variables that drive the outcome, and then how do they relate to each other, and then you can use full probability distributions for each one of those nodes and begin to do some pretty sophisticated macroeconomic analysis, which we're doing with some of the world's banking and asset managers. So how is this being incorporated into corporate risk management and business continuity planning? I believe that the last OML seminar was given by my friend, colleague, and advisor who told you about, Steve Wilson, who told you about hidden climate adaptation, which is to say it's happening in businesses, but they don't always call it climate adaptation. They call it these other things. Well, so in the strategy realm, it might be choosing where to locate your agricultural assets or your supply chain or your your human resources. Where is it going to be just too hot or too wet to lean into? And I did some work with a large multinational oil and gas company, and they discovered some strategic opportunities in biofuel in some parts of the region. In some parts of the world. There's also risk management and resilience. This is something that happens all the time, and climate data is now just getting mainlined into a normal old risk management discipline through enterprise risk management, business continuity planning, and increasingly stress testing, particularly in the financial system. Make sure that your held assets can adapt to or can deal with the stresses that climate change, the acute stresses that climate change might throw at you. Responsible investing, you can look at your portfolio of invested assets and monitor that for climate risk and see what type of risk you have, and then strategic asset allocation is looking across different stocks and bonds and different alternative investments and trying to adjust your risk accordingly by using climate-aware capital market assumptions. How is climate likely to impact GDP, consumer price index, inflation, all those kinds of things that you do when you're an asset manager. And climate value at risk is an increasingly exciting field to understand. And finally, compliance and reporting. I'm sure many of you have to do compliance reports on climate already. Those are moving from a qualitative assessment to ever more quantitative assessments, as I'm sure you're dealing with. Many different sectors have to make decisions based on climate. Some of you have asked questions about telco and airlines and so forth, and we've worked with, you can see here some of the questions that they're interested in, that we've assessed their assets. I'll just say that we can, most clients want to understand several different time periods and several different scenarios, high emission scenario and low emission scenario, and get to the actual numbers, the actual dollars or pesos or whatever currency that you are looking at, so that you can then make actionable decisions about what kinds of mitigation, let's say abatement, you want to do, carbon emissions abatement, and those usually have a range of cost-benefit analyses, and also so that you can make decisions about what kind of adaptation you want to do. Adaptation also has a cost-benefit analysis. You invest in strengthening your resilience, and you spend X number of dollars doing that, and then you expect a reduced risk in return. And it's important to be able to justify that to the people making whether it's your board, the people making that investment through a risk analysis. I'll just leave you with a couple of challenges faced by companies and then also by the risk analytics community. The first is the tragedy of the horizons, which is a term made famous by, his name is slipping me at the moment, the European Central Bank, Mark Carney. And it refers to the difference in time between the causes of climate change and the effects of climate change. So if I was to be able to tell you very precisely what's going to happen in 2050 to your company or your asset, it might be hard for you to know what to do with that information right now because of the way that our systems are set up with the different timescales. So that's something that's very important to tackle, and it perhaps a double bottom line might help. New models, all of these are new, even though they're being mainstreamed. People are asking lots of questions about how do you know? What should we expect? How do you know this is real? And how do you know it's going to really work out this way? and what scenario to pick and so forth. So they're all new models. We're all learning together, and that can inhibit companies from actually taking action, is just the uncertainty of it. Speaking of an uncertainty, the models themselves are uncertain, scenarios are uncertain. However, what's not uncertain is that delay is more costly than taking action. It's like saying, well, I don't know what's going to happen, so I'm not going to buy a life insurance policy. No, bad idea. You should still buy the policy, even if you can't predict with certainty what's going to happen. And then balancing simplicity and complexity. The number of graphs that I've shown you just in the past few minutes alone show how complex this stuff can get. And yet we need to be able to make some fairly simple business decisions. I'm just going to leave you with, there are many, many lifetimes and careers worth of work left to do to increase the certainty on all of this modeling. Everything from coupling the physical and transition risks to some of the things we've already talked about, thresholds and tipping points, and coupling microeconomic and macroeconomic approaches. If you're interested, I'd love to talk through more of that in the questions if we have time. But I think I'll leave it there for the time being. And thank you again for the opportunity to share with you.